Okay, we're going to begin with a two-part note-taking session on energy. So we have already talked about the fact that everything in the universe is made up of one or two things, either energy or matter. Matter is the stuff, and energy is moving that stuff around. So matter is the substance, and energy is the mover of the substance. How do we know energy exists if we can't actually see it or feel it or touch it? We can't often feel or touch energy, but we can see when energy changes from one form into another, when it's converted. And then it can be transferred from one place into another place. So we can see those transformations and transformations. So energy has something that we call has a dual nature. Energy occurs in tiny lumps called quanta. Um, and energy we're going to define as the ability to do work. And the unit for energy is the joule. So there are two basic types of energy. Just like when we had matter and we were able to divide matter up into heterogeneous and homogeneous, we can divide all energy in the universe into two types: potential energy, which is energy of position or stored energy, or kinetic energy, energy of motion. So if we look at potential energy, this is energy stored and held for readiness. One type of potential energy is a form called gravitational potential energy. It's due to something having an elevated position. If I hold a book over somebody's head, they're kind of concerned about that because that book has the potential, if I just get it moving, to do some work on somebody, doesn't it? Okay, I can, so there is a type of potential energy called gravitational potential energy, energy of position. Gravitational potential energy is at its maximum at the highest height. So if I hold it just over somebody's head, not so bad. But if I hold it, I get on a ladder and I hold it a story above their head, then we can see that there would be more potential to do work there. So the equation for potential energy is often, or the potential energy that an object has, a gravitational potential energy, is often the weight of the object, okay, times the distance. So potential energy, to find the potential energy that something has, I can use the equation mass times gravity, or the weight of the object, times the height. Now, kinetic energy is energy of motion. So I can find the kinetic energy that something has using this equation: half the mass times the velocity squared. Now, if I offer somebody $100 or maybe an A in the course if they allow me to use them in a demonstration. So a student says, okay, yeah, you can use me in a demonstration. So I put them out in the parking lot and I say, to get your A in the course, all I'm going to do is I'm going to drive this VW Volkswagen at you going 2 miles per hour. Okay? And you can't get out of the way, you have to leave it bump into you. So you think that's something you could do? 2 miles per hour? Someone's a little VW Beetle? Sure, probably. So I drive my VW Beetle going 2 miles per hour and I bump into you, and you might get a little bruise on your leg or something wherever I happen to hit you. You might fall down, but no big deal, and you get your A for the course. But what if I told you I'm going to take that same VW Beetle, and instead of driving at you at 2 miles per hour, I'm going to drive at you at 100 miles per hour? Now, that doesn't seem like such a great deal, does it? So speed has a lot to do with how much kinetic energy something has, the ability of something to do work, to place a force on something, okay? The same is true if I offered that same deal to you, but instead of driving a VW Beetle at you going 2 miles per hour, I drive a Mack truck at you going 2 miles per hour. Not so sure that's such a great deal to get an A in the course, because, you know, um, the more mass something has, the more kinetic energy it has, the more ability it has to do work. So we can use the equation kinetic energy is half the mass times velocity squared. Now remember, this 0.5 is not part of the sig fig, it's part of the equation when we start doing some problems. Okay, that ends part 1 of our energy notes, and we will be talking a little bit more about energy conversions and transformations in part 2.